Okay, so we are doing more on 7.4 today. Let's go do a little bit of review here. Parallelogram. How to prove a quadrilateral is a special parallelogram given points. You need to check 4 shapes. Okay, for a parallelogram, in order to prove that they are given the shapes of a parallelogram. So the first one, remember number 1, a parallelogram, it's either you have multiple ways for parallelogram, opposite sides, congruent, opposite angles, congruent, right? Opposite sides, parallel, consecutive, angles, supplementary, and the last one, opposite, and diagonals bisect. So bisect diagonals. Next are rectangles. You have to have the same rules as the parallelograms, but on top of that, our angles, all angles congruent. Our rhombus, all of our sides are congruent. And then their square is everything's congruent. Just everything is congruent. The sides, angles, diagonals, whatever. So let's now, how to prove a quadrilateral is a rectangle versus a rectangle. First, we want to use the distance. Diagonals. We want to prove that the distance on the diagonals are congruent because the diagonals of a rectangle are congruent. So here, write that down, congruent. Well, let's start up here. We have our points. So let me graph this really quickly here. First, I'm gonna put in the coordinates. All the numbers are positive, so I'm just gonna make my XY here on the edge. Since all the numbers, the coordinates are positive here. So my X and my Y axis is on the edge. So the first one is 2, 3. This is A. 5, 9. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9. This is B. The other one is 11, 6. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6. This is C. And D is 8, 0. Okay, so this 1, 2, 3, 4, 5, 6, 7, 8. So this is D. Connect these dots to show you the quadrilateral here. Right, let's prove that it's a parallelogram. First, use the midpoint formula on the points of each, to find the points of each diagonal. Okay, so first we got to draw on the diagonals. The diagonals are BD and AC, like so. Let's find the midpoint of BD in red. Midpoint of BD is, we want to add from up here from our coordinates. So add our x's, 5 plus 8 divided by 2, 9 plus 0 divided by 2. This gives me, this gives me 5 plus 8 is 13 divided by 2 and 9 divided by 2. I'm just going to leave it as is because 13 doesn't divide well by 2 and 9 doesn't divide well by 2. Now I'm going to do AC. AC is up here, 2 and 2, 3 and 11, 6. So 2 plus 11 divide by 2 and 3 plus 6 divide by 2. This gives me 13 halves and 9 halves. They both match. The two of them match, so they have to be parallelograms since both of these match. Next, we want to prove to see if it's a rectangle, right? Because rectangles are parallelograms. So now we can use the distance formula to determine the length of each diagonal. Remember, in a rectangle, all the diagonals are the same length. So let me do that for BD. BD first, the distance is x minus x, so 5 minus 8 squared plus 9 minus 0 squared. That gives me negative 3 squared plus 9 squared, which is the square root of 9 plus 81, which is the square root of 90. I don't need to know the exact decimal for that because I just want to check to see if the other one, AC, is the same. So here, square root of 2 minus 11 squared plus 3 minus 6 squared, which is 2 minus 11 is negative 9 squared plus negative 3 squared, which is 81 plus 9. It's the square root of 90. These two are the exact same. Here's check mark here. It is a rectangle. What can you conclude about the length of the diagonals in the figure? Well, they are the same. They are the same. So we have a rectangle for sure. So for sure it is a rectangle. All right. Next, we're going to prove if a quadrilateral is a rhombus. There are a couple ways, but the first way to prove that it's a rhombus is that we are going to use slope on the diagonals to show how they are perpendicular. Because remember, the diagonals form a perpendicular in the inside of the rhombus. So let's graph this. All the units are positive. So I'm going to make my XY here axis on the outer edge. So this would be my X and this would be my Y axis. Let's graph A is 1, 1. A. B is 5, 3. 1, 2, 3, 4, 5. 1, 2, 3. B. C is 3, 5. 1, 2, 3. 1, 2, 3, 4, 5. C and D is 7, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And that is D. So if I connect these, here is my rhombus. Okay, first we need to prove that it's a parallelogram because it always has to be a parallelogram before it can be proved anything else. So the midpoint, we got to find the diagonals. So I'm going to do AD and CB for their diagonals. Let's start with AD. AD is 1, 1, 7, 7. So 1 plus 7 divided by 2. And 1 plus 7 divided by 2. That gives me 8 divided by 2. And 8 divided by 2, which is 4, 4. 4, comma 4. Let's do CB, which is 5, 3, and 3, 5. So 5 plus 3 divided by 2. And 3 plus 5 divided by 2, which is 8 divided by 2 and 8 divided by 2, just like the last one. It reduces to make 4, 4. So we got a parallelogram going on here. Now let's prove that it is a rhombus. We're going to do this by using the slope formula. Remember, the slope formula is our change of y's over our change of x's. So let's do a slope of, slope of AD. And the slope of AD is, where's AD? AD is 1, 1, 7, 7. So our y's are 1 and 7. So 1 minus 7 over 1 minus 7. This gives me a negative 6 over negative 6, which is also a positive 1. Let's do slope of CB, which is 5 and 3. So 5, the y's on top, which is 3 minus 5 over 5 minus 3, which gives me negative 2 over positive 2, which is negative 1. And those are inverse relationships of each other, opposite inverse, so they are perpendicular to each other. So we have a rhombus. What can we say about the lengths? We can say that AD is perpendicular to CB, so we have a rhombus. Next, how to prove a quadrilateral is a square. Okay, first we can check the rectangle by using our distance to show that they are congruent, and then we also check the slope to show that the diagonals are perpendicular, using the diagonals here. So let's graph this. We got some negative coordinates, so I'm gonna put this in the middle. Our xy axis, just like this. X, y, we have 0, negative 3 for A, so this is A. 3, 0, that's B. 0, 3, that's C. And negative 3, 0, that's D. Okay, so if I connect this, here is my supposed square. We got to find the midpoint using our midpoint formula for our diagonal. So if I drew our diagonals, this is BAC and this is BD here. So let's do the diagonal of AC first. AC being 0, negative 3, and 0, 3. Our x's are 0 plus 0 divided by 2, and our y's are negative 3 plus 3 divided by 2. Well, all of that is 0, 0. Our midpoint of DB is 3 and negative 3. So we have 3 plus negative 3 divided by 2, and 0 plus 0 divided by 2. That gives me the same 0, 0. Prove that they are a rectangle. Well, to prove they are a rectangle, we got to show the lengths are the same using the distance formula. So we'll start with AC. AC has the square root of 0 minus 0 squared and negative 3 minus 3 squared, which is 0 plus negative 6 squared, which is square root of 36, which also is just plain old 6. dB, in this case, we have 3 minus negative 3 plus 0 minus 0 squared gives me 3 minus negative 3. Well, that turns into big old positive. So this is 6 squared plus 0. So this is the square root of 36, which is also 6. So these are the same. Number 4, we want to prove that it's a rhombus by showing that they are perpendicular using slope. So the slope of AC, our y's first. Our y's are negative 3 and 3. So negative 3 minus 3 over 0 minus 0. Oh, that is a vertical. So that is a vertical up and down slope. Our slope of dB, because it's being divided by 0, or basically dB is here 0 minus 0, 0 minus 0, and 3 minus negative 3, 3 minus negative 3. Well, that's 0 divided by 6, which is 0. So these are perpendicular to each other, and it is a square. So to prove that it's a square, is this figure both a rectangle and a rhombus? And it is, yes, it is both rectangle and rhombus, so it is a square.